Good afternoon, everyone. Welcome back again. Our team has built a rocket, which shows a demonstration on how these rockets explore the outer world for fascinating and discovering of new things. And as we can see, we have built our rocket based on hydraulic systems, and we have shown how this simple rocket using these hydraulic systems can create motions which propels it to move faster to the outer space. You see, our model works using hydraulic pressure. It has two connected syringes filled with water. When we push the plunger of one syringe, the water therefore forces the other syringe, which pushes the rocket upward. And it is also used in real life. For example, in heavy machinery liftmen or in places where main labor is lacking behind and where people can easily use it. And the way we have built this project relies on a scientific principle as well, which I would like to say it is Newton's third law. And it is also another scientific term again for Pascal's law. It's a two theory actually. For Pascal's law, it states that when pressure is applied to a confined fluid, it is transmitted equally in all directions. Hence, we can see before that when the rocket has moved, we push one syringe to the other end using a tube connecting it. We fill it up with fluid to make it easier, the pressure, the stronger. The denser the fluid, we want it more. As we can see, we can use air, but fluid is more easy to use as it is denser. Now that we have applied force to the first syringe, that pressure that moves through the water instantly and pushes on the second string, like it goes up like this. Because fluids are nearly incompressible, as I have stated before, almost all the force is transferred without loss. Hence, we can see that the rocket has easily moved up. Now, in workstations and air space stations, sometimes systems like this, hydraulic systems, are used, and it is very useful actually, since there can be any means of no ends in the scientific world. We can use different kinds of methods, and one such example is this hydraulic pressure. The pressure we have created, if we are to put into a scientific term, it can be written as P is equal to F by A, where P is pressure, F is for force, and A is for the area. By changing, we can increase or decrease the output force, which is to say that even a small push can generate a large amount of pressure to thrust it upwards, the rocket upwards. Now, we would like to demonstrate it again once more to really prove what I'm talking about, and you will see for yourself. Now we can see that the fluid here in the first syringe has been pushed through this. Here, as we can see, this fluid, it has been pushed forward to the second syringe. Thus, we have proved that by changing the location of the fluid, from transferring the pressure, the fluid density from one syringe to the other, we can increase or decrease the push force. Even the small push from this syringe can generate a pressure so strong that it can even push this rocket upwards. This type of scientific theory is often used in day-to-day life, and this can be referred to as hydraulic system. And now the pressure location change has also caused the rocket to come back down safely again. This is how important and how useful hydraulic systems are. Through this model, we have shown how hydraulic systems and Pascal's law and Newton's third law of motion can be used to demonstrate or convert a small mechanical force into powerful motion. The way we have built this rocket is such that it is educational and it is really useful for learning small sciences in and out of home. Even in school, it is simple, easy to make. It doesn't require much effort, and this is really educational. Through this kind of models, we can learn, students can interact in group activities, they can learn together, they can revise, they can learn beyond classrooms. It is really useful for us. And thanks to this project, once again, we have recapitulated our learning on physics, on fluid density, on Pascal's laws, on